All right, guys, we are approaching the end of Algebra 2 Honors here. We just have a couple more things to go over, a couple more days of new stuff. If you remember that formulas, or excuse me, not formulas, the identity sheet that I gave you last week, there are a couple identities at the bottom, the sum and difference identities and the double angles. What I wanted to talk to you today is about the sum and difference identities, or the sum and difference formulas as they're sometimes called. Normally, I would say you guys got to know these really well. You're going to have to memorize those because you're going to need to use them on a test. But since all our assessments, our skills assessments are open notes, you don't necessarily need to memorize these at all. I think it's good to be familiar with them, though. These are a little bit tricky to prove. So I'm going to do something I don't normally like doing, but the interest of time, especially given where we are in the year, I just want to review these with you real quickly, just kind of go over what they mean, but we're not going to go over proving them. If you're really interested in proving them, I know there's some good websites out there that can prove this to you, but I want to show you how we actually use these, so I don't want to get bogged down in the proofs of them. So I know you have them on the worksheet, so we're not going to spend too much time on them, but I did want to just quickly review them. So if we have something like sine of alpha plus beta, so two angles, right? Sine of alpha plus beta, it is equivalent to, okay, the sine of alpha times the cosine of beta plus cosine of alpha times sine of beta. Okay, and you might say, well, why is that useful? It just seems like you're taking something somewhat simple and making it more complicated. Well, you'll see in a minute why it's useful. Sine of alpha minus beta, so two angles subtracted from each other, is almost identical. Sine of alpha, cosine of beta, but it's minus cosine alpha, sine beta. Again, alpha and beta just represent two different angles. Cosine of alpha plus beta would be cosine of alpha times cosine of beta, okay, minus sine alpha sine beta. Cosine of alpha minus beta would be cosine alpha cosine beta plus sine alpha sine beta. So for the cosines, the sign in the middle, SIGN, is opposite of what is inside the parentheses on the left, whereas the sine function, SIN, it agrees. So just notice the difference in there. It's good just to be familiar with them. And then tangent of alpha plus beta, this is kind of the crazy one, is the same thing as tangent of alpha plus tangent of beta all over 1 minus tangent alpha, tangent beta, and then tangent alpha minus beta, pretty similar as you can guess, tangent alpha minus tangent beta all over 1 plus tangent alpha, tangent beta. Okay, so those are the 6. I know you have them. You don't need to memorize them, but I just wanted to quickly run through them with you again, give you a sense of what they mean. But now I kind of want to show you how we use them. How is it useful? So it says find the exact values below. Cosine of 75 degrees. I know we haven't done many trig values or trig ratios with degrees as the input, but I gave us some degrees on this worksheet because it's actually a little bit easier to see using degrees how these sum and difference formulas are useful. It's a little bit harder with radians. We can still do it with radians, and as you see, you've got some radians here and further on in the worksheet, but I wanted to start off with a few angle ones, or excuse me, few degree ones that are simple. So normally you might say cosine of 75. Can't do that, Mr. Bunny. We don't know 75 degrees. That's not one of our special triangle angles. It's not a reference angle we're used to. The reference angle here is 75 degrees, and you'd be right up until the last 5 minutes. Now though, we have the tools to solve them. So what I would be thinking about initially, if I see cosine of 75 degrees, is all right, it's not one of my normal special angles. Is it possible that I could, though, make up 75 degrees using the sum or the difference of two special angles I do know? And while there are actually probably an infinite amount of answers, the most obvious one might be 45 and 30. If I rethink of this as cosine of 45 plus 30, right? 45 plus 30 is 75, so I should be able to write it that way. That would be equivalent to cosine of 45 right, times cosine of 30 minus sine of 45 times sine of 30. Now, all of those are ones that I should know. So cosine of 45, root 2 over 2. Cosine of 30, root 3 over 2. Sine of 45, root 2 over 2. Sine of 30, 1/2. If I combine these, I get root 6 over 4 minus root 2 over 4, which is just root 6 minus root 2 all over 4. So you can see how the cosine, or the cosine sum and difference formula here was really helpful. It allowed me to break down 75 into two smaller angles that I knew. Okay, so doing all this without a calculator. So let's take a look at number 2, cosine of pi over 12. Now again, you should be thinking, pi over 12 is not an angle or a reference angle I'm familiar with without a calculator, so there must be a way that I can combine, either by adding or subtracting, two special angles to get pi over 12. Now you can see it's probably a little bit harder to do this with radians, so I just might be thinking, all right, let me put my special angles into 12. So pi over 6 and 12 is 2 pi over 12. Pi over 3 is, oops, it's 4 pi over 12. Pi over 4 is 3 pi, okay. If I do 4 pi over 12 minus 3 pi over 12, that's going to give me pi over 12. So I could rethink of cosine of pi over 12 as being cosine of pi over 3, which is 4 pi over 12, minus 3 pi over 12, which is pi over 4. So cosine of pi over 12 is the same thing as cosine of pi over 3 minus pi over 4. And using my sum and difference formulas, I'm just going to write this below. That would be cosine of pi over 3 times cosine of pi over 4, right, plus sine of pi over 3 times sine of pi over 4. Now, just to speed this video up along, because I know you can do it, if you find the values for all those angles and combine into one fraction, you'll find you get root 2 plus root 6 over 4. Okay, root 2 plus root 6. I trust you can find the cosine of pi over 3. I just don't want to spend too much time getting bogged down on that. All right, so number 3 and number 4 are pretty similar. They're kind of, right, just using some different angles here. So if you feel like you want some more practice on them, feel free to do those. Check out the answers on Canvas. They are posted, okay? But I do want to move on to maybe some other problems. You can also see it in reverse if we take a look at number 5. Sine of 80 times cosine of 20 minus cosine of 80 sine of 20. We don't know any of those off the top of our head, but you might recognize, oh, that's really just the sine difference formula, right? That is really the same thing as just sine of 80 minus 20, which is the same thing as sine of 60. And I know sine of 60 is the same thing as, or is equal to, root 3 over 2. So part of this will be using your ability to recognize what those formulas are. So not only do you want to take what's on the left and make it, if we go back to these identities up here, not only would you start with something disguised as this, right? You might also start with the right side and need to convert it back to the left side there. Okay, so that's what kind of makes these a little bit tricky, and why I think being really familiar with these, not even though you don't have to memorize them, being familiar is going to be really helpful. Okay, 6 is very similar. I'll let you guys kind of tackle that. I do want to get to this one, because we will see some identities, proving some identities using these. It says, can you prove that cosine of pi over 2 minus theta is equal to sine over theta using the sum and difference formulas? You might recognize, if you when we were back in school, which seems eons ago, this is one of our cofunction identities. It's also on the identity sheet there. It's a cofunction identity. It's a cofunction identity, and I want to prove it, okay, using my sum and difference formulas. Well, this is just cosine of the difference of two angles, so this would really just be cosine of pi over 2, okay, times cosine of theta, I'm just changing the left side, okay? Plus sine of pi over 2 times sine of theta. Okay, that's going to be equal to the right side. Well, cosine of pi over 2, this guy right here is 0. So 0 times whatever cosine of theta is does not matter. That's just going to go away. And I'd be left with just what's on the right side of that left, or the right term on the left side. Sine of pi over 2, which is just 1, times sine of theta. So I'm just left with sine of theta equals sine of theta. And I proved it using my cosine difference identity. Okay, so you can see how this is useful as well. I know I'm throwing a lot of identities at you, but you guys have one advantage that previous years kids do not, is that you have a sheet that you can reference. You don't have to memorize all of these. Okay. All right, there's one more problem I want to go over with you guys together, and then that's going to be it for the video here. It says find cosine of alpha minus beta given cosine of alpha is equal to negative 15 over 17, and alpha is between pi over 2 and 3 pi over 2, and sine of beta is equal to 4 over 5, and beta is in between 0 and pi over 2. If you feel up for it, okay, feel any feeling adventurous, you could pause the video, give it a shot. Even if you're not sure where to go, I think it's really good practice to practice problems where you're not exactly sure what to do. When you think about tests and assessments that you take, right, a lot of times you get to a problem you don't know what to do and you got to get creative. So this might be a good situation where you try that. Even if you're like, I don't really even know what to do, take a shot at it. If you're really not feeling up for it, you certainly could just walk it through with me. But if you want to hit pause right now and do that, I would encourage you to do so. Okay, so let's fill out what we know. We don't know what alpha or beta actually is, but I do know that the cosine of alpha is negative 15 over 17, and its angle's in the third quadrant, and I know beta's in the first quadrant, and I know the sine ratio. So what I'm actually going to do is just draw out a few triangles. Let's do alpha first. That's in the third quadrant, so I'm going to draw a triangle in the third quadrant. There's alpha, and I know the cosine of alpha is negative 15 over 17, and if I use my Pythag that I know, that must be negative 8. I also know that beta is in the first quadrant. Okay, let me just make this a different triangle just so we don't assume it's the same angle, just in a different quadrant. There's beta. And I know that sine of beta is 4 over 5. That must mean this length is 3. Okay, so it's just setting up the triangles. We've done problems like this before. All right, and it asks for cosine of alpha minus beta. Well, I know that, cosine of alpha minus beta is going to be equal to cosine of alpha times cosine of beta plus sine of alpha sine of beta. Now, at this point, it's just a matter of using the triangles to figure out what those ratios are. So cosine of alpha is negative 15 over 17. Cosine of beta is 3 over 5. Sine of alpha is negative 8 over 17. And sine of beta is 4 over 5. Again, I'm just using the triangles there to figure those out. All right, if we combine the term on the left, I get negative 45 over 85. On the right, I get negative 32 over 85. Very nice. They all simplify. They all have the same denominator, and that gives me negative 77 over 85. That's equivalent to cosine of alpha minus beta. Okay, so I think these sum and difference formulas, while they seem intimidating, are actually kind of useful. There's a lot of situations where you can use them to solve problems that you otherwise might not have. All right, so number 9 is pretty similar. If you want to give number 9 a shot, obviously feel free to do so. I don't think there's anything too tricky going on, different than what we just did. And then 1, 2, and 3 under more identities, I think are interesting. Okay, so I'm going to have that just be your homework here. So just problems 1, 2, and 3, proving those 3 there. Now the solutions are on Canvas. Again, I encourage you to work through as much as you can. Fight through that period of frustration or I can't do it. I believe in that you guys can. and then check the solutions after. These are identities, so there may be one or more ways to do them. So if you guys find an interesting way of doing them that's different than I did, save it, circle it, and then when we meet in class next time, let me know. I'd be curious to see how you guys might have proven these. Okay. All right. So that is it for this. We will meet again tomorrow.